I'm Shoeb Javed, Chief Product Officer for iGraphics. So my role is to work with our customers and help them transform their business to better meet their mission, right? So the idea is how can our customers transform their business so they're more aligned with what their original mission is and how they can actually succeed to do what they started out to do, okay? All right. Part-time, I'm also a philosopher. So if you want to ask questions about happiness or the meaning of life, etc., come find me afterwards, and I'll be happy to oblige, okay? All right. Okay. So I'll skip the agenda. So if you have a good marketing department, they'll normally give you a slide like this, right? The slide is, everything is broken, everything is wrong. The reason for that is because then you can say, this is how I fix it, right? So I got one. I got one where, all these things happen, there's a storm brewing, so on, so forth, right? But I do have a serious question for you, right? Transformation projects have a very high failure rate, okay? Can somebody tell me why? Anyone, just throw an idea out there, right? Why do you think transformation projects fail so often? Change management, okay? Sure. So incremental approach as opposed to a big bang one. That's a good one. Anybody else? Fear of failure? Skill set gap? Lack of definition of success. I like that. Everything cannot be transformed. There's no reason to transform. Sure, that's a good one. Okay. So I think, there are a couple of main reasons as I work with customers on this, right? The first one is people are too focused on the solutions, but not enough on the problems, right? So you normally start by saying, I got this cool technology, I need to apply it to my company. Why? I don't know. I mean, my competitors are doing it, therefore I should do it, and hopefully it will result in some form of success. As Kinesh says, I have no idea of what that success looks like, but I want to do it anyway because everyone else is doing it, right? So this is the fear of missing out, right? FOMO. You've heard of FOMO, right? I'm doing something because I'm afraid that I'll miss out, and therefore I got to somehow get something done, but I really don't know why, right? So that's one reason. You don't know why you're transforming, you don't know what success looks like, you don't know how to measure it. It seems straightforward, but that's primarily why all these transformations don't work out. It's not the technology for the most part, right? The second part, I think, is a lot of people that have experience are not open to being wrong, right? So this is a problem. Because things change so fast, if you rely on past experience, successful or unsuccessful, it's not going to help you that much, right? So you got to be open to being wrong. And this is something you have to learn because it's not natural. Your brain is always pattern matching to success from the past, right? So you got to break that to say, I need to really look at everything from scratch, right? So people don't do that. So there's this Mark Twain quote, right, that I'm going to leave you with, and then we get into it, which is, it ain't what you don't know that gets you into trouble. It's what you know for sure that just ain't so, right? So that's mainly the fact that you know what you are doing, and you think that's the right thing, but it's not, right? So that's what gets you into trouble. Okay. All right. So has anybody heard about digital twins or know what that means? Okay, I got very few people, right? So what exactly is a digital twin? A digital twin is a digital representation of some physical thing, right? It could be a complex piece of machinery, it could be a plant, it could be an organization, it could be anything, right? So any physical thing, you have this digital representation, which is more or less accurate as it represents that thing, right? So that's a digital twin. So why would you have one, right? Why would you need to have a digital twin? And the main reason is because you want to tinker with it, right? You want to try different things to say, what would happen if I do this? What would happen if I change that? How would it work if I added additional parameters and so on? And you can do it without a lot of expense, right? Because in the real world, if you implement it, you try it, you fail, it takes too long, it costs too much. But with a digital twin, it's like software, right? You can change your mind as often as you like. You can try all kinds of experiments. And therefore, it's really important to have that representation of whatever it is that you're trying to improve or decide to improve. And the one that I'm talking about is digital twin of an organization. So it's not of a physical thing, it's about your company. So what that means is that your processes, that your people, your systems, everything that goes into making up your business. So if I create a digital twin of that, then I can, of course, improve your business, right? I can actually add parameters, run experiments, I can try different things, and I can see how that works, and if I like something, I can go implement it, okay? That's the idea of a digital twin. All right, so what are we modeling, right? We are modeling systems, assets, people, processes, data, and we are doing that because we want to actually visualize complex things. We want to then design and analyze and improve upon those complex things. We want to monitor, we want to predict, we want to optimize, and we want to automate, right? So again, a lot of people just jump into automation or optimization or whatever it is without actually understanding or having a model that tells you whether you succeed or fail or indifferent, right? So having this model and looking at it comprehensively in a multi-dimensional way is what a digital twin of an organization is, okay? So again, we break this down to see how you practically go about it, right? Okay, so how do you build this? So there are 3 parts to it. Again, it's high level, of course, each part gets complex, but we'll get into that, right? So the first part is discovering how you do business today, right? It's easier said than done, but this information can come from many different places. It comes from your enterprise applications, it comes from your people, what's in their heads, it comes from documentation that you might have. So there's a number of pieces of information that come together to actually help you understand what you're doing today. What do your processes look like? Who is doing it? Where do you have risks? Where do you need controls? All of those things is called discovery, right? Once you do have that understanding, now you can make things better, right? So this is where the design component comes in. In the design component, what you're doing is to say, I know where I am, I know where I want to be, what do I change, and how do I collaborate to make those changes to get me there, right? So that's the design part. And then you have optimization. So once you have a design and you run it, you're watching it execute, and as it executes, you can say, okay, I can tweak this, I can tweak that, I can predict what's going to happen, and in anticipation, I can change things, right? So 3 parts to that: discover, design, optimize. And part of that optimization, again, isn't in the rear view mirror, right? So a lot of optimization, you look at what happened 6 months ago or a year ago or whatever and say, hey, this happened, and therefore I should do something so that it doesn't happen again. So again, this is where the experience leads you astray. The current state of the art isn't to look in the past. It is in some ways, but it's to use that past information to predict the future, right? So you say, okay, I anticipate this is going to happen, and therefore I need to take action now so that it doesn't happen, right? And this is where predictive analytics and some of the advanced simulation capabilities come in that can actually predict what's going to happen and then allow you to bypass it, right? And not actually have it happen and then deal with the problem, right? So those are the 3 components. And again, if you delve deeper into it, right, what are process models, right? They're straightforward. They're not just pictures of the process. You've all seen BPMN process models, or you've seen diagrams of processes. That's not the only thing, right? There are also entities that are tied to it, right? There are people, there are systems, there are strategies, there are risks, there are controls. There's all kinds of metadata that goes along with how you run your business, right? It's not just a picture on a piece of paper. It's a lot more than that. So that's what a process model is. You then also have technologies for mining your processes. So what process mining does is it reverse engineers your process flows from information stored in your applications, right? So maybe you use SAP, or you use Salesforce, or a number of other applications to run your business. Process mining can collect data from those applications and will show you how your process works. It can then visualize and create a model of your process based on looking at that information and then giving it to you, right? And what it can also do is it can say, look, I have a model. I think I'm doing this, and actually I'm doing this. So how closely do they conform, right? So it can tell you whether your real-world processes actually conform to what you think you're doing and how you have modeled them. And ideally, they should be close to each other, right? You can also collaborate. You can design new processes. You can run simulations. And of course, you can, on an ongoing basis, get insights from all that data so you can actually improve your processes, okay? So we went back from let's focus a little bit more on the problem and why and what I should improve. And then I can apply technology to go improve it. And then I have a built-in way of measuring whether it succeeded or not, right? Because there are certain KPIs that got improved. I can look at it month over month or quarter over quarter and see whether it's actually doing it. And then I can use predictive analytics to anticipate the future and then apply investments in the right area, okay? So far, does it make sense? Why you would do a digital twin and how you would go about it, right? Okay. So let's look at, how does this look like, right? So if you were to use Gen AI to build a process model, what does that look like, okay? So let's look at this, right? So the idea here is, right, I'm typing a simple question up there. Give me a process to make coffee, right? So I'm asking Gen AI, I need a process that makes coffee. I'm using a simple example to illustrate the concepts, right? So once you ask that question, we get some answers back, and then we use that to create this model. So now you noticed you just asked a simple question, a model came up. You can also modify it. You can say, okay, now give me a process that says, I need a decision whether I'm grinding the beans or not grinding the beans, right? So it'll give you that decision. So it's pretty straightforward, right? I'm asking questions, I'm getting answers, I'm building models. I can even take standard operating procedures, documents, just dump them in, and then it will actually generate a process based on this, right? You go over here, right? You see the nice process. It's an order-to-cash process. And of course, I can update it as I go along, right? So again, it says add another activity, says create manual code, put it in a different swim lane, and there you go, right? So it's going to add another new one. You'll see that show up. So I'm not drawing this. It's not cumbersome. I'm not writing documents. So people can actually do this, right? They can transfer information from their head over into something like this. And then once they have it, they can edit it, right? So now you got this model. You can edit it, right? So again, now we are asking it to add more context and notes, right? So for each of the activities, let me find more information. And so it's adding those annotations you notice over there. And then you can look at those annotations. And of course, you can load pictures, right? So any random thing like a diagram, it generates a process out of it. You can see it, right? But the whole idea here is, right, I can combine information from pictures, from documents, from things I have in my head, or anything else to get you a more accurate representation of your process. And then once I have it, I can keep it up to date. So this is the problem, right? So when you have documents or process models or whatever, they're only as good as the most current version of it. And of course, process mining helps because you're getting that data from systems and you're building that out, right? So that's an example of Gen AI being used to construct process models or construct digital twins. Now, this is interesting because last year in Dubai, when we had this conference, I was joking that if I don't mention Gen AI in my presentation, it's not going to be good because everybody has to mention Gen AI somehow. But now we actually have something that's useful and working, and it's there. So the pace at which this is happening is quite rapid, right? So you can see where from I was making a joke until I'm showing something. It's not a long time, right? So that's one part of it, right? The other part is simulation, right? So again, what does it mean to simulate? So what do? So once you have a process design, like I was showing you those pictures, you can say, I now need to run my enterprise data through this process and see what happens, right? So how long does it take me to do something? What's my customer experience look like? What should I change, right? So you can do things like decision support, right? So what is the return on investment for buying a piece of machinery, right? How will my cost be impacted if I swap materials? Any number of things that allow you to make a decision, a business decision, can be run through, and you can see what happens. So it's not an intuitive gut check when you make decisions. It's based on things that you can actually measure, right? You can also do what-if analysis. You can say, hey, look, Christmas is coming up. If I hired 5 more people in my store, how much more revenue will I get? Should I hire 5, or should I hire 4, or should I hire 3? Right? So you can start to do those kind of what-if analysis to see how you would optimize your operations, right? You can make predictions and projections. You can say, based on past data that you have collected and 100,000 instances of execution of that process, this is what's likely to happen, okay? And then you can do root cause analysis, right? You can say, if something goes wrong, why did that happen? Where was the problem, right? So sometimes, automation is not the default answer. If you automate something upstream and a downstream task is the bottleneck, it doesn't do you any good, right? I mean, I can build products a lot faster, but if I can't ship them, then they're just sitting in warehouses, and I got inventory costs, and I haven't fixed anything, right? So again, just making something better or faster upstream may not help you, right? Because the downstream bottlenecks will just kill it. So again, you can actually do those kind of root cause analysis. And again, you can see some of this, right? So you can actually see the results come out from simulation. You can see, how does the process play out? What's the baseline, and so on. But this gets more sophisticated now, right? So what happens is I run a set of data. I get one simulation results, right? I can run other sets of data, and I can feed the results of the simulation into an AI model that will now tell me what should I do to optimize which parameters, right? So I can do trade-offs now. I can run hundreds of these simulations, even thousands of these simulations in the background, constantly with different parameters. I can look at each of the results, and I can say, if I wanted to optimize for this KPI, I would use this set of parameters, or I would use those set of process designs, right? So that gives you a lot of options and flexibility as you go along. So once again, right, what I did was I took very complicated physical things, people, processes, systems, all of that. I digitized them through discovery and through design. And now I have this whole thing that I can play with. I can play with it almost every day, every second, every minute. Doesn't matter, I'm constantly evolving, right? And when I find the right answer, I can then spend my precious money to go build that and see what it did, and then repeat the whole process again, right? So that's simulation, right? And then predictive analytics, right? So this is something that's really interesting to me. We've been doing a lot of research on this, mostly in our development center in France. But the idea here is that, say you are building, say you're Boeing, right? You're building aircraft body, right? Now, it's a complex process, right? It might have thousands of steps to build something as complicated as an aircraft body or a hull, right? And I've built hundreds of them or thousands of them, even tens of thousands of them. So what I can do is, if I'm on step 10 of a 100-step process, I already know what the other 90 steps are going to look like, right? I can project that. And what I can do if I project that is I know I'm not going to make a delivery deadline, right? I know that I'm already behind on step 10, and I'm never going to get there, right? Or if I know that if the process takes this path, in the past, that has caused failures of that process, and something is wrong, so I need to make an alert to say, go fix this now. Right? Don't wait for another 6 months. Don't wait for another 3 months. Go do this now. Right? So we can predict task durations. We can predict paths. We can predict what's going to happen. And also, I think Samir mentioned compliance, right? Compliance tech. That's a big area now on how do you actually make sure that you're complying with regulations, separation of duties, all that stuff. I can monitor a running process and tell you that you have skipped a small compliance step in the beginning, which would cause you a large compliance problems in the end. Or, by the way, if it goes undetected, that's going to cause you a huge fine or a reputation loss, right? So again, I can monitor those processes in real time, but you don't have to do it real time. You can monitor it every day, right? Or every other day. I can point out a lot of things for you that didn't exist before, and that's where the whole predictive analytics comes in. Okay, so just a little bit of a plug for our company, right? So far, it's all been abstract things that you do, and we do that, right? So we have a platform that today can actually help you discover your processes with process mining, help you model, help you simulate. Everything that I talked about is not some future thing that's coming. It exists today, right? And so we're doing this, different levels of sophistication with different customers. And it's truly amazing what kind of difference it actually makes when you do this. Okay, so that's what my company, iGraphics, does. We build a process intelligence platform that helps you construct these digital twins and then helps you optimize your business in a much more thoughtful manner as opposed to just throwing money or technology at a problem. Okay? All right, so a real-world case study again. I picked this one because I like it, right? So this is a healthcare company that has dialysis centers, right? They also do dialysis equipment. So if you have kidney problems and you need dialysis, you have to go to these centers and you got to get it, right? So if you are a dialysis patient, you can't travel, right? It's a problem, right? I can't just pack my bags and then go somewhere the next day. I have to figure out how I'm going to take care of the dialysis and all these other things. So this company wanted to rationalize their processes by building a digital twin so that their customers could just walk in to any of their centers in over 30 countries without worrying about it, right? You show up, they know who you are, you get what you need, you go on your way. Now, it's not that simple because every country has different regulations, different insurance things, different ways to get paid and reimbursed for medical things. But just imagine, right? So if you digitize your process, you are actually making a difference in someone's life, right? They can now be much more mobile, much more flexible, don't have to worry about it, show up at the beach in the afternoon, go get your thing done, right? No paperwork, nothing to fill out, right? So these are the kind of ways when you do transform what you do, your original mission, right, which is to help people, which is to make sure that having a kidney problem that requires dialysis is not a big deal, right? And so that's where I think some of these abstract technology ideas we talk about actually get realized in the real world. Okay, and that was my last slide. All right.
Thank you, Shoeb.
Have any questions?
Yes, plenty of questions.
Okay.
How do you approach the balance between automation and human oversight in digital twin solutions, primarily to ensure reliability and trustworthiness?
Yeah, so again, right, I've been in this automation space for, I don't know, lots of time, years and years, my white hair kind of proves it. But you don't do automation for automation's sake, right? It's very important to have a purpose for why you're doing automation. And that's why I believe that people are always going to be required to discern why you're doing it and why it's important and how it fits in, right? So I think people will always be required, even if you have lots of automation, to actually make it work, because it's the questions that are much more important these days than the answers, right? So how do you actually ask a question that would then lead to automation and the right answer, right? So I'm not worried about automation replacing me. I hope it does, because I don't want to work much, but it hasn't so far, right? So I don't think that there's any problem of people being replaced. We have 3.5% unemployment in the US, so it hasn't actually worked.
Thanks for that people-centric approach. Would the effort in building a digital twin overweigh the benefits? How do enterprises estimate the value of the investments involved in building digital twins as opposed to working directly on transformation initiatives without building digital twins?
Yeah, so you got to be pragmatic, right? If you have a small transformation project, of course you wouldn't build a digital twin. So you have an incremental approach. Don't build a digital twin for your whole company all at once, right? Build it for a department, build it for some processes that you feel are strategic, and then do more. So I think you can build up on incremental successes and get there, yeah.
In simple words, is digital twin the same thing as combining ML and process automation, or there is more to it?
No, there's a lot more to it, right? It's not just combining ML and process automation. It's actually understanding how your business works at a fundamental level, and then using that understanding to drive the transformation, right? So it's doing it the right way. Not having technology first and then finding the problem to solve. It's understanding the problem and then using technology to solve it. It's a subtle difference, but an important difference.
You did share an example of a healthcare case study. So are there any other example where this has been adopted and benefit reaped out of?
Yeah, lots. I mean, retail is an example, telecom, Retail would be like, say, for example, you're a big retailer. You can see what number of cashiers you need to place in the store when, right? So how does the traffic pattern flows through your retail processes? If you have a customer-facing process, like you're a telecom company, people call you, you can build a digital twin of that process to say, how do I not ask the same question 100 times, right? Or how do I actually optimize? So there's many, many different areas where this can help. Yeah.
Great example, thank you. What key metrics should we prioritize when gaining visibility into our current business processes?
Yeah. So metrics fall into like 2 or 3 main categories, right? There are metrics related to cost, there are metrics related to capacity, and there are metrics related to end user experience. And you can say, okay, is the end user experience getting better? Can I build more of the things that I want to build, or am I doing it less expensively? And of course, within each, you can have a number of metrics. Yeah.
So in continuation to the metrics, what tools you use to acquire the necessary metrics for the simulation?
Yeah. So what you do is you actually connect to source systems through some kind of iPaaS system, right? So you take data through APIs from, say, Salesforce or Workday or other systems. Once you get that data, you can then build KPIs or metrics which are consolidated from multiple systems and show up at different parts of your processes. It's a fairly straightforward thing to do because those systems do collect a lot of data. You just have to filter and get the right ones. Yeah.
What is the most unexpected use of DTO have you seen? A couple examples of unusual application will help.
It's, in my experience, there have been more straightforward corporate examples, but if I wanted to provide an unusual one, think about building a digital twin of yourself, right? Your digital twin, and then think what you can do with it, right? So that would be an unusual example where you can say, I have modeled myself, and then how can I fix things and what would happen if I do, right? Maybe I could become less obnoxious. I don't know, something like that.
Can this be applied for software development processes
Yeah,
and
absolutely.
simulate scenarios like improving teams' velocity or software quality?
Yeah, yeah, absolutely. We do that all the time. Yeah, because again, half the problem is visibility, right? So if you know what you're doing, you can improve it. If you don't know what you're doing, there's no chance.
So is this iGraphics only about existing processes?
No, it can also be about new processes. Yeah, it's not just about existing.
Can we create a digital twin of a participant in the clinical trial?
Sure. Yeah, I mean, there's enough data there to do that. It's not quite accepted by the FDA because you still have to have the real human person there, but you could do a lot of it with a digital twin before you actually get to people, right? Or even animal trials.
So while doing that, how do you think we can effectively identify and measure inefficiencies and bottlenecks in building a digital twin?
Not the inefficiencies and bottlenecks are typically of your operations, not the digital twin itself. What you have to think about on the digital twin side is how accurately does it represent my real world processes, right? And for that, the more data you can collect or the more fine-tuned you can make it, the better off it's going to be.
Okay, thanks. So for us to be able to simulate an organization, what kind of inputs iGraphics simulator will take?
So it can take inputs about your overall corporate strategy, about your IT systems, about your organization, your people, your processes. Any number of parameters can be modeled. And once you do, you need to figure out where you're collecting the source data. And then once you get that, you can run the simulation.
Sure. So in these parameters, how do you think they can be represented or simulate humans and behavioral aspects?
Well, it's harder to simulate human behavior, but you can simulate roles, right? So you can say, okay, this particular role does this, and on average, what do they do? There's something called task mining, right? So what task mining does is it actually observes people doing work, and as they do work, it finds patterns of what they do, and therefore you can then model what someone's going to do, how efficient they are, how long it takes. It's not about an individual person, it's like across a collective group of people to get that information.
Thanks, Shoeb.